Hello and good day everyone. Welcome back to my YouTube channel. My name is Sir Marcy and the topic that I'm going to discuss today is all about the graph of quadratic functions. Let's recall first how to transform quadratic function into standard form or vertex form. In our example number 1, let's say we're going to convert y is equal to x squared minus 4x minus 2. Our step number 1 is we're going to group those terms containing x. Next is we're going to factor out a. Since our a here is 1, we're going to divide this by 1. So that's x squared divided by 1. The answer is x squared. Negative 4x divided by 1 is negative 4x. Then we're going to add blank space here. Minus 2 minus blank. So we're going to make this a perfect square trinomial. And to do that, we will multiply the second term by 1/2. So our second term here is negative 4 multiplied to 1/2. And the answer now is negative 4 times 1/2. That is negative 2. Then you square it. The answer is positive 4. So we will add 4 here. And then here, we're going to multiply it by 8. The number that we get here, multiply it by 1. So that's 1 times 4. Then we simplify. We now have y is equal to the quantity x squared minus 4x plus 4. Then simplifying this, we have negative 2 minus 4. So I did not write 1 here anymore because by convention, we know that there is an invisible 1. Next is we're going to simplify. That is now x squared minus 4x plus 4. Negative 2 minus 4, that is equal to negative 6. Then, we can convert this perfect square trinomial into square of binomial. That is, y is equal to, get the square root of the first term, square root of x squared is x, then copy the sign of our second term. This is negative, so that's minus. Then square root of our last term, square root of positive 4, that is 2, raised to the second power minus 6. So this is now our answer in standard form or vertex form. So to get the vertex, we get the opposite of negative 2, which is positive 2, then copy the value of the constant here, which is negative 6. So this is now our h and our k, which serves as a turning point of our parabola. Now, I'm going to present another solution. In converting y is equal to negative x squared plus 2x plus 3, I'll use a different method. First is we're going to solve for h. The formula in solving for h is negative b all over 2a. And to solve for our k, we're going to use the formula f of h. So first, we're going to identify the value of a, which is negative 1, b, which is equal to 2, and c is equal to 3. So let's solve first for h. So that is negative b all over 2a. We have negative times b, which is 2, all over 2 times negative 1. So negative times 2, we have negative 2, all over 2 times negative 1, we have negative 2. So negative 2 divided by negative 2, that is positive 1. Next is we're going to solve for k. So k is equal to f of h. Take note that the value of h here is 1. So that's f of 1. We're going to evaluate the quadratic function by substituting the value of h equal to 1. So from negative x squared minus 2 plus 2x plus 3. So we plug in positive 1. So negative times 1 squared plus 2 multiplied to 1 plus 3. So k now is equal to negative 1 plus 2 plus 3. So simplifying this from left to right, k now is equal to positive 5. Oh, sorry. k now is equal to positive 4. Next is we're going to rewrite it in vertex form. We know that the vertex form or the standard form is y is equal to a times x minus h squared plus k. So we plug in the value we have a, h, and k. So y is equal to a, which is negative 1 multiplied to x minus the value of h, and that is 1 squared plus the value of k, which is positive 4. So we simplify it. We now have y is equal to negative times x minus 1 squared plus 4. So this is now the vertex form or standard form. And the vertex here, we have 1 and 4. Okay, let's now proceed with our lesson, the graph of quadratic function. In our last lesson, we discussed that the graph of a quadratic function is called parabola, a parabola that may open upward and downward. Also, we discussed about the vertex, which is the turning point of the parabola. So the vertex h and k is the lowest or minimum point if the parabola opens upward. That is the case if a is greater than 0. So I have here an example of a parabola that opens upward with vertex at 0 and negative 3. So take note that this parabola opens upward and can be classified as concave up. All parabolas that open up will have a positive a value. The vertex is the lowest point or the minimum point. Next is I have a vertex which is the highest or maximum point if the parabola opens downward and the value of a here is less than 0. So this is an example of a parabola that opens downward where the vertex is at 1, 6. Take note that this parabola opens down and can be classified as concave down, and all parabolas that opens down will have a negative a value. The vertex is the highest point or the maximum point. Okay, let's now proceed with the line or the axis of symmetry. The line or axis of symmetry is the line that separates the parabola into two equal regions. Its equation is x is equal to h from the value of h in the vertex h and k. So from our previous example, we have here a parabola that opens upward. Take note that the vertex is the turning point of the parabola and the vertex here is at 0, negative 3. So to find the axis of symmetry, so that is the line that separates the parabola into two equal regions. And the value of our axis of symmetry is x is equal to h and h here is equal to 0. That is why axis of symmetry is x is equal to 0. In our example number 2, we have a parabola that opens downward and the vertex is at 1, 6. So we're going to draw the line or the axis of symmetry, and we notice that the axis of symmetry is at x is equal to 1 since our h here is 1. Okay. Also, the parabola may have two intercepts. When two real distinct zeros, one x-intercept tangent to the x-axis, where there is one real zero or no x-intercept when the zeros are non-real. Okay. So here the x-intercept is at negative 2, 0 and also 2, 0. So since the parabola touches the x-axis, we have 2 points. We have negative 2, 0 and 2, 0. On our example number 2, the intercept is at negative 1, 0 as well as 3, 0. Next is we're going to determine the y-intercept. And every parabola has only one y-intercept. That is when x is equal to 0. So here, in our example, the value of our y-intercept is at negative 3. Okay? And in our example number 2, the Y-intercept is at y is equal to positive 5. Let's now talk about the domain and range of the quadratic function. The domain and range of the quadratic function can be easily determined by looking at the graph. Since the parabola opens upward or downward, the domain of any quadratic function is always set to all real numbers. In our previous example, the domain here is all real numbers because we can plug in any values of x in our quadratic function. The vertex of the parabola sets the limits of the range of the quadratic function. If the vertex h and k is the minimum point, then the range of the quadratic function is y such that y is greater than or equal to k. If the vertex h and k is the maximum point, then the range of the quadratic function is y such that y is less than or equal to k. In our example, notice that the vertex is the minimum point or the parabola opens upward. The value of our h is 0 and the value of our k is negative 3. So to find the range of the quadratic function, since our vertex is the minimum point, we just simply write y such that y is greater than or equal to k. Our k here is negative 3. That is why the range is y such that y is greater than or equal to negative 3. Next is the example number 2. So the domain here is again all real numbers because if we plug in all the values of x in our quadratic function, it is still a real number. To get the range, notice that the vertex is at the maximum point, which is located here. Or we know that the parabola opens downward. Next is to find the range, that is simply y such that y is less than or equal to k. So our k or our h here or the vertex here, h is equal to 1, k is equal to 6. Since the value of k is 6, the range is y such that y is less than or equal to 6. That's all for now. Thank you for watching and please don't forget to like and subscribe to my YouTube channel.